Back. This is the third static equilibrium problem. It's called the printing press. So we've got a table. It's kind of like a beam supported by two pillars. It's 20 meters wide or 20 meters long. Halfway across, we're going to count the mass of this beam, which is 1,500 kilograms. We're actually going to count its weight. So we're going to have to multiply that by 9.8. 15 meters across, we've got our printing press. We need to solve for F1 and F2. Obviously, F2 is going to be larger because the printing press is pushed over and it's closer to that side. So, how do we do this? We take the torque from here. So if we're going to take the torque from 0, it'll be 0 force times radius. The force will be times 0. So let's try. Torque. Here we go. Starting here. At 10 meters, we've got the weight of the beam. So at 10 meters, we've got the weight of the beam, which is mass times gravity. Now, because this is pushing downward, I'm going to make this negative. At 15 meters, I've got the printing press, which is 15,000 kilograms times 9.8. That's also pushing down, so I'm going to make that negative. At 20 meters, I have this force, which I don't know, but I do know that it's upward, so I'm going to count that as positive. At 20, I have F2. So this entire quantity is equal to 0. Why? Because it's not moving. It is a static equation. So I'm going to quantify this, and I'm going to solve for F2. Let's do that quickly. 1,500 times 10 is 15,000. 15,000 times 9.8. I have a negative 147,000. Negative 147,000 plus a negative 15 times 15,000 times 9.8. A negative 2,205,000. They're negative, plus 20F2 equals 0. But we can move 20F2 to the other side, and everything can become positive. So let's do it. 20F2 equals this plus this. Plus 147,000. 20F2 equals 2352000. Divide each side by 20, and F2 equals 117,600 newtons. So that's how we solve for F2. I'm running out of space, but next we have to solve for F1. So if you have to watch this more than once, do so. I'm going to erase that. So I now know that this is 117,600 newtons. So the easiest way to figure out F1 is all of the upward forces and all of the downward forces should balance out. So I call this technique ups and downs. You could take the torque from this side and do exactly like we did last time. You'd get the same answer, but I think ups and downs is easier. However, you don't need distances. We're just going to look at the forces. So we've got F1 going up. We don't know F1. So what's the second thing we have? We have the force of the beam, which is 1,500 times 9.8. It's pushing down. It's negative 14,700. We've got another downward force, 15,000 times 9.8. That's 147,000. That's negative. And then we've got this upward force of 117,600. So if I add all these up, it should equal 0. I've got two upward forces, this one and this one, two downward forces, those two, which I counted as negative. So when I move, let's just solve for F1. So I've got 117,600 minus 147,000, and then minus 14,700. I've got F1 minus 44,100 equals 0. F1 equals 44,100 newtons. Most of your problems in this chapter will be like this one. You'll have bridges with trucks on them, but you can always come back to this example. So this is the printing press.